Hello, my name is Irina. I would like to talk about Appalachian Plateau's aquifers and about acid mine drainage which we have here. I live in southeast Ohio close to the Hawken River, the tributary of the Ohio River, and here we have the Hawken River Valley Aquifer, one of many aquifers in the large aquifer system located on the Appalachian Plateau's physiographic province. This is the aquifer we take our water from. Out of the 13.7 million people living in the Appalachian Plateaus region, 2.4 million people take their 163 million gallons of water per day from the aquifer by domestic wells. 3.6 million people receive 286 million gallons per day from public supply, and 7.7 million people use 1,500 million gallons per day from surface water. But these 7.7 million people, even though they use surface water, also depend on groundwater because groundwater accounts for 50 to 65% of annual stream flow of the surface water. If the water level under the ground drops significantly, some streams may even dry out. The rocks that make up much of our aquifers are sandstone, siltstone, shale, limestone, and coal. These rocks' primary porosity is low, especially compared to unconsolidated sediments. But the porosity and permeability of these aquifers are increased by joints and fractures formed due to tectonic movements in the ground. But still, these fractured rocks have low capacity, and underground aquifers in the region are very sensitive to the climate conditions. Fluctuation of precipitation rates and evapotranspiration rates would significantly affect the water level underground. Since the climate here varies from humid continental to humid subtropical, the precipitation is relatively evenly distributed throughout the year. So the climate is very gentle to the aquifer system and doesn't cause any significant long-term problems with water balance here. The impact of people's activities on the water quantity in this region is also not too large. Even though underground water is a very important source of water in the region, people withdraw significantly less water from the aquifers compared to other aquifers in the United States. What is the real problem in southeast Ohio is water quality. In some areas in the river valleys, there is more sand and gravel, so we also have some alluvial and outwash aquifers, especially in the Ohio River Valley. Our aquifer is one of them. They are particularly vulnerable to pollution because they are shallow, have high permeability, and are not protected by a sufficiently thick layer of clay. Among different sources of water pollution, some are usually more common for a certain region. Domestic waste and sewage leakage is a problem virtually everywhere where people live. Agriculture is more common in the central and western parts of Ohio where the terrain is flatter. In our region we have mostly forests, and this keeps us relatively safe from chemicals used in agriculture. Most of the industrial parks are located along the Ohio River. You can easily find them on Google Maps. Many of them are chemical plants. It is hard to tell what impact each of those plants has on the environment, particularly on water quality. If chemical waste is disposed correctly, then perhaps everything that ends up in the ground is just clean water. If there are any violations in this process, we would have our water contaminated. Groundwater can be also contaminated by precipitation if harmful chemicals become airborne. In this case, pollution can spread over a wider area. To find out how dangerous a particular facility is for the environment, it is necessary to conduct a thorough investigation. Drilling for oil and gas is a large, heavy topic, and people are very concerned about this everywhere in the states, including Ohio. Around 20-30 million barrels of radioactive oil and gas waste are disposed of in the injection wells drilled in the bedrock. They leak through the cracks and faults and contaminate the groundwater. Here is an interactive map that I found on the internet. You can type the zip code, find the county you would like to check, and see where the wells are. Coal mining. I would like to go into more detail on this topic. Coal mining started here in Southeast Ohio around 1800 and marked the beginning of the settlement and development of the region. In some locations, the Appalachian Plateau's aquifer system was significantly altered by coal mining. Many long tunnels were carved out in the ground. When a mine was abandoned, they stopped pumping water out of it. This led to the formation of a special, artificially created kind of aquifer. Abandoned coal mine aquifers, large pools consisting of underground labyrinths. Sometimes water can travel through these labyrinths over tens of miles. Local water budget was greatly affected. Those deep mines and spoiled materials increased the base flow, and now they serve as channels for the groundwater, through which it discharges to the surface, lowering the water table and redirecting the flow. I imagine this like having a hole in a plastic bottle. You cannot add more water than it would fit below this hole. In some cases, these tunnels cause water to flow from one basin to another. Under the influence of moisture and air, pyrite minerals in the mines decompose, forming sulfuric acid, which lowers pH level in the water, and a lot of dissolved iron salts, which colors the streams orange when it seeps to the surface. This was the beginning of an environmental issue of our region known as acid mine drainage. Excess metals and very low pH level are harmful for the living organisms in the stream, and many of them die. High concentrations of these substances can even cause the stream to become completely lifeless. One of the affected places is Sunday Creek, a tributary of the Hockin River. 7 miles of the stream was filled with large amounts of iron after the explosion of the air shaft in the 1980s. There are people who do their best to restore places like this one. One interesting project was organized here by Ohio University faculty, the True Pigments Project. They decided to create business out of the pollution to make the stream cleaning financially self-sustaining. They use iron oxide pigments to make paints, and they sell those paints. This is interesting. Their office is in my town close to my home, and I learned about them only when I started working on this project. I found their page on Facebook. They have a short movie on YouTube named Toxic Art. It shows the Orange Sunday Creek and tells about the process of how they make the paints. We must be very careful with changing any natural process in our environment. The consequences are often unpredictable, negative, and sometimes irreversible. I think people should be taught from childhood to take care of nature.